Assalamualaikum, my name is Enrozia Kabir, matrix number 211091998. Power system protection is a branch of electrical power engineering that protects the electrical power system from fault by isolating the faulted part from the rest of the electrical network. So the objective of the power system is to detect abnormal condition, selectivity remove fault area, keep power system stable, rapidly remove fault, and lastly to ensure continuous supply.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nik Sabrina binti Muhammad Nasi. Today I want to talk about type of fault in power system. Fault in power system is categorized in two main factors, which is short circuit faults and open circuit faults. In short circuit fault, here it have further categorized, which is symmetrical fault and unsymmetrical fault. In symmetrical fault happen in balanced condition, and it happen in all or three phases in power system. While in unsymmetrical faults, it happen in one or two phases in power system. In unsymmetrical faults have three types of fault, which is single line fault, line to line fault, and double line to ground fault. Single line fault, it happen in single conductor to short to the ground, and line to line fault, it happen when two conductor is short to the ground, and then double line to ground fault, it happen when two conductor is short together, is contact together and short to the ground.
For the components of power system protection, instrument transformer is one of them. It protects the equipment from high voltage in power system, regulates and measures equipment, and it supplies correct current and voltage values. This instrument consists of current transformer and also voltage transformer. Next is protective relay. It detects fault in the system by activates the circuit breaker to isolate the faulty part, and relay measure electrical value to spot abnormal conditions. So when a fault is detected, the relay triggers the breaker to trip. This action removes the faulty conditions. And as for the circuit breaker, it's an electrical device used to protect circuits from fault like short currents. It works both manually and automatically. So the main function is to interrupt the flow of current during a fault to ensure the stability and the reliability for the protection to work. And next is the fuse. Fuse is a short piece of metal in the circuits, so it melts when there's too much current, and then it breaks the circuit. It's connected in series with the circuits to be protected. So during a short circuit, the current increase, which it melts the fuse, and then it disconnects the circuit. And lastly is the batteries. It provides power during power outage. So even when there is no incoming power, the circuit breaker can still be operated using battery power. So it allowing them to trip during faults. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Izzati binti Hamdan, and I will present about the challenge in the power system protection. So power system protection faces several significant challenges, including coordination issues and fault stripping. So for the first one, coordination issues are critical as they can affect the reliability, safety and stability of the power grid. One of the primary issues is the coordination of the protection setting. Different protection devices in a power system are typically set to operate in a coordinated manner, where the device closest to the fault operates first to isolate the fault while ensuring that the other part of the system remain unaffected. However, with the integration of the renewable energy source and the addition of the new grid component, the system fault characteristic and fault current can change, requiring adjustment to protection setting for a proper coordination. So for the second one, fault stripping in a power system protection is a significant challenge that can lead to unnecessary outages and equipment stress. The occurrence of the unnecessary outages in the area with the actual fault, which can disrupt service for customer and businesses. These frequent outages can damage the credibility of the power provider and lead to customer dissatisfaction. And the aging or faulty device become more susceptible to malfunction over time, often resulting in the fast reading. Additionally, in the system that depend on communication for protection coordination, any failure or latency in communication can lead to false trip. Repeated false tripping and subsequent re-energizing cycle can stress electrical equipment, reducing its lifespan. So high in-rush current during re-energization can cause additional wear and tear on the equipment.
Technology used in power system protection, which is the first one, numerical relay, which can offer an exact and reliable protections, control and monitoring of electrical system. So this relay is based on the microprocessor, which can set up to perform various tasks including monitoring, control and measurement. This relay has the advantage of increase of reliability, adaptability and the performance. The protection scheme can be improved through the programming. But this relay has a limitation, which is the failure of a single component can lead to the entire system, which can lead to the protections of loss. The second technology is digital signal processing, DSP, which are used to analyze the real-time data from the power system and enable the accurate detections of fault and abnormal condition. It can also use to identify the types and location of fault and perform appropriate control to isolate the fault area. So the advantage of DSP is that it has high accuracy, it has simplicity of data storage and time sharing. But the limitations of DSP is that the power consumption is high and then the greater of the complexity due to the AD converter and DA converter. The third is the communication system, which enable the real-time data transfer from the control center to the field equipment such as RTU and IED. The advantage of this technology is that it provides a fast simultaneous of clearing of all internal line fault and also prevent the overtripping on the external line fault. But the limitation of this system is that the noise and the various change of speed can affect the system performance. The last technology is the Global Positioning System, GPS, which can provide the exact timing and synchronization for fault identification and location. The advantage of GPS is that the ease of applications and also the low cost. However, the limitation of GPS is the reliance on the satellite, which can cause any problems in a specific condition.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Sarah Binti Zakaria. Okay, I will talk about the emerging trend in power system protection. Okay, I will focus into two types of the modern trend in the power system protection, which are IED, Intelligent Electronic Device, and then second, ML, Machine Learning. Okay, what is the IED? IED is the device that equipped with the advanced communication and processing that allow the protection to be more faster and more accurate. One of the advantages of the IED is it can quickly detect and respond to the fault in the protection and help to minimize the damage to the equipment. Meanwhile, IED also face with some challenges, which is cybersecurity risks. It is because IED have the communication network that can have a high possibility to be hacked. Okay, next I will talk about the machine learning. Machine learning is a division of the artificial intelligence that focus on the algorithm. In context of power system, ML use technique to analyze data, identify patterns, make prediction, or control and protection for the power grid. This technique can be used for a task like fault detection, fault location, disturbance detection, and other applications in the power system. ML have a pattern of recognition, effectively recognize complex patterns and relationships in the power system that can be beneficial for the fault detection. Next, ML can adapt to a new data, allow the improvement in the performance of the power system protection. One of the case study IED in the power system protection is the implementation of the IEC 61850 standard-based IED in a substation automation EC61850 offer scalability and flexibility for future expansion and integration of additional devices or functionalities in substation automation project.
The outcome of this study is to understand the importance of advanced technology. Understanding this aspect is very important in improving the electrical grid reliability and efficiency. This modern technology can allow for quickly and precise problem detections, isolation, and for recovery operation of the power system. The second outcome is to recognize the significance of adaptive protection schemes. The dynamic response capacity will enable the protection system to rapidly adapt to the fault conditions. An adaptive protection scheme will use the modern algorithm to improve the selectivity and sensitivity of the protection device. The last outcome is gaining insight to the future trends to meet the growing demand. The advanced protection method will be required to ensure the efficient integrations of renewable energy source into the grid, and that AI algorithm is used to evaluate the big, massive set of data and make significant recommendations.
In conclusion, power system protection is vital for the reliability and stability of electrical networks. It uses very real protective devices to detect and mitigate faults, ensuring system safety and preventing equipment damage, while the integration of renewable energy and advanced technology has improved protection system. Moving forward, the adoption of AI, data analytics, and smart grid capability will be essential in enhancing predictive maintenance and efficient renewable energy integration, ensuring sustainable energy future.